Welcome to the video on Bistable Multivibrator. In this video, I am going to discuss about the introduction of Bistable Multivibrator, circuit diagram, output waveform, and applications of Bistable Multivibrator. What is meant by Bistable Multivibrator? As the name suggesting, bistable, it has two stable state. That is called as Bistable Multivibrator. So in the previous video we explained about the different types of multivibrators. Now let me see what are the features of bistable multivibrator. It has two stable state and the circuit can stay indefinitely in either of two stable states. And also it will need external trigger pulse to change the one stable state to another stable state, and this circuit is also called as flip-flop circuit. And let me see the features of monostable multivibrator. So this kind of multivibrator has only one stable state, and the next state can be called as quasi-stable state. It need external trigger pulse for changing from stable state to quasi-stable state, and there is no external trigger pulse need for quasi-stable state to stable state. It is also called as one-shot and uni-vibrator. And the features of a stable multivibrator are it has two quasi-stable state and there is no external signal is required for changing the state. It is called as free running multivibrator, and the applications it will produce square waveforms, so it is called as square wave generator. So and yes, this slide shows what are the conditions if the transistor got on condition or off condition. And this diagram shows if the transistor is off condition means the collector and the emitter terminals should be open circuited and there is no collector current in this terminal, so IC equal to 0, and VCE, collector to emitter voltage, should be given as power supply VCC. The same power supply should be given here, so VCE equal to VCC. If the transistor will be on condition means the collector and the emitter terminal should be getting short circuited. So here there is more current in the collector, so IC equal to IC saturation, and this VCE, collector to emitter voltage, should be given as 0, right? And now this is the circuit diagram of bistable multivibrator. So let me see the concept. Now here we are using two transistors Q1 and Q2. This Q1 and Q2 can be crossly coupled. So this Q1 is the first transistor and Q2 is the second transistor. Both the transistors are identical NPN transistor, and this transistor should be connected as crossly coupled. You can see the collector of the Q1 should be given to the base of the Q2 through the resistor R1, and here the collector of the Q2 should be given to the base of the Q1 through this R2 resistor, and RL1 is nothing but as load resistor of Q1. This RL1 can be also called as RC, and this RL2 is the load resistance of Q2. It is also called as RC resistor, collector resistance. And here this R1 and R2 are equal value of resistors, and this R3 and R4 are equal value resistors, and this VBV is nothing but as biasing voltage. The biasing voltage can be given to the base of Q1 and base of Q2, and this is set pulse. The set pulse should be connected to the base of the Q1 through a capacitor, and this reset pulse can be connected to the base of the Q2 through this capacitor. And now we can see what is the operating principle of this circuit diagram. When we give some power supply to this circuit, what will happen is this Q1 and this Q2 should be start to conduct. So let us assume that Q1 is the on condition and Q2 is the off condition. So if the Q1 should be on condition means, in the previous slide I explained, if the Q1 transistor should be on means this collector terminal and this emitter terminal of the Q1 should be short circuited. So the collector current should be given as IC saturation, and this VC1 collector voltage of Q1 is equal to VC saturation. So that is almost 0. The voltage value of this VC1 should be given as 0. And if Q2 is off means this collector and emitter terminal of the Q2 should be getting open circuited, so there is no collector current in the terminal, so IC equal to 0, and this VC2 collector voltage of Q2 should be given as power supply VCC, right? So when the VC1 should be 0 in the Q1 on condition, the VC1 should be 0, almost 0 means the minimum voltage can be given to the base of the Q2. So that minimum voltage should be less than the cut-in voltage, so automatically the Q2 should be turned into off condition. So this is the first condition of this bistable multivibrator. So if you want to change the transition from Q1 on to off and Q2 off to on means we have to set a trigger pulse to this circuit. So now we should apply a trigger pulse, this reset pulse to the base of the Q2. So when we apply this reset pulse to the base of the Q2 should be on and this Q1 should be off. Okay, if the Q2 should be on means, again what is the condition? The collector and this emitter terminal of Q2 should be short circuited, so IC equal to IC saturation, and this voltage across the collector 2 should be given as VC saturation, almost 0. And here the VC2 have minimum voltage 0 voltage, that is given to the base of Q1, so that voltage should be less than this cut-in voltage, so the Q1 automatically gets turned off. So if Q1 is off means the collector and emitter terminal of Q1 should be open circuited, so there is no current in the collector terminal of Q1, so IC equal to 0 and VC1 equal to VCC. So it's going on, and again we want to change the transition means again we have to set a set pulse to the base of the Q1. So after applying the set pulse to the base of the Q1 start to conduct, that is Q1 is on and Q2 is off, and the process is going on. And here this is the same circuit of bistable multivibrator. In this circuit and this circuit and the previous circuit and this circuit will be same except a small change. The change is here a capacitor should be connected parallel with this R2 and this R1. So two capacitors are connected. The two capacitors are called as speed up capacitors of bistable multivibrator. So what is the need for connecting this capacitor means this capacitor can change the transition very fast. Okay, so it will change the transition as very fast. Without capacitor, the transition of one stable state to another stable state, it will take some time, but by using this speed up capacitor, the transition should be very fast. And now we are going to see about the output waveform of bistable multivibrator. So here I am using some 6 time slots. So Q1 is off, Q2 is off, Q1 is on, Q2 is off, again Q1 is off, Q2 on, Q1 on, Q2 off, Q1 off, Q2 on, Q1 on, Q2 off, and it is going on. So the first graph is the collector voltage of Q1, and this is collector voltage of Q2, and this is trigger input, that is a reset input, and this one is trigger input 2, that is set input. So what will happen if Q1 is on? Okay, so just see the condition. If Q1 is on means what is the value of VC1? VC1 equal to VCE saturation. So here VC1 equal to VCE saturation, right? At the same time, what is the status of Q2? Okay, here you can check Q2. If Q2 is off means the value of VC2 is equal to VCC. So Q2 is off means the collector voltage of Q2 should be given as VCC, right? And second time slot Q1 is off means, so Q1 is off means the VC1 equal to VCC. So now it will change the state VCE saturation to VCC, that is this state. And again for VC2, it will change the state from VCC to VCE saturation. So it comes like this. Okay, and third time slot again, if Q1 is on means VC1 equal to VCE sat. Here if Q2 is off means VC2 equal to VCC, and the same process will be going, and the same process will be continuing. So here after this state, the second state should be changed, right? So when we are applying the reset pulse, yeah, here you can see the signal, this is a reset pulse. When we are applying this reset pulse, now you can see clearly the VC1 can be changed from VCE sat to VCC, and the VC2 can be changed from VCC to VCE sat. And this fourth graph, when we are applying trigger input 2, the VC2 can be changed from VCE saturation to VCC. So this is what logic 1, 0, 1, 0, 1, 0, and it going, and it moves on. So this is the output waveform of bistable multivibrator. So please students, you should remember these conditions. What are the conditions if Q1 is on, Q2 is off, and what are the conditions if Q1 is off and Q2 is on? And applications of bistable multivibrator. So it is used to perform digital operations such as counting and storing. It is used as memory elements in the shift registers and the counters. It is also used in computer memory, and this kind of bistable multivibrator, it is used to generate and process the pulse types waveforms. And overall, the bistable multivibrator is also called as flip-flop circuit. Okay. Thank you.